Hey class, today we're going to look at solving polynomial equations and what that means. So a polynomial equation would look like this. It might not be to the fourth power, but it's some equation with variables raised to different powers. So our goal is to get what x is equal to. So we're going to start by looking to see if there's anything we can factor out. And we can factor out a 2x squared from every single one of our terms. So we're going to do that. That leaves us with x squared minus 5x minus 36. And now what's inside parentheses is a trinomial. And we know how to factor quadratic trinomials, so we're going to do that. The parentheses factor to be x plus 4x minus 9. Now this equals 0 is important. We're going to solve that. We've done this before. Set each of these pieces equal to 0. So I did that in this step. 2x squared is equal to 0, and then both the parentheses are equal to 0. And now we're going to solve. So this one we would divide by 2. 0 divided by 2 is 0. And then take the square root, and the square root of 0 is 0. And then obviously subtract 4, add 9. We get these three answers as our solutions. You're going to see the word solution be used. You'll also see roots and zeros. All three of those things mean the exact same thing. Okay, here's another one. 4x to the third plus x equals 4x squared. We need to get this in standard form, which means we need to set it equal to 0. So we subtract the 4x squared, put it in standard form, and now we factor. So we can take an x out of each. That leaves us with 4x squared minus 4x plus 1. That factors to be 2x minus 1 and a 2x minus 1. And at this point, we can set each piece equal to 0. Notice these two pieces, or our two parentheses, are the same equation. So we get x equals 0 and then x equals 1/2 two different times. Instead of writing this x equals half 2 times, we're going to call it a double root. Double root means that it occurs 2 times. Another way to define this double root would be talking about multiplicity. And multiplicity describes how many times that root occurs. So in our previous example, x equals 1/2, we call the double root, but we can also say it has a multiplicity of 2. So here's another example where we're going to find our roots and then give the multiplicity. So we can take an x cubed from each term, and then we can factor our parentheses to x plus 4, x plus 4. Well, now when we set each piece equal to 0, x to the third set equal to 0 would be x equals 0. And then both of these give us a root of x equals negative 4. I went ahead and wrote in the multiplicity below. So 0 has a multiplicity of 3 because of this x to the third. Technically, x to the third is x times x times x. And we could set each of those x's equal to 0, which is where we get that multiplicity of 3. And similarly, if we set each of these parentheses equal to 0, we would get negative 4 as a root 2 different times. Maybe. There we go. Here's another final example. This is a quartic raised to the fourth power. Here's our equation in standard form. And now we can factor this. Instead of an x in the front, there's going to be an x squared in the front. And now both of these are difference of 2 squares. So that becomes an x plus 1 and an x minus 1 for each parenthesis. So we're going to have two different roots, or two different solutions. We're going to have x equals negative 1 and x equals positive 1. And both of them have a multiplicity of 2 since they occur twice in this step.